Okay, in this video I want to take a look at all the transformations all put together into one function. See how we can deal with that. Generally it's straightforward except for one thing, and I want to point this out. I want to look first of all at the graph of y equals x squared, and I want to look at the graph of y equals 2x plus 4 squared. Okay. What does it look like? Y equals x squared, your standard parabola, right? What happens over here? Well, you can say the 2 is multiplied by the x in there. It must be squeezing it by a factor of 2 in the x direction. The 4 is being added on. It's shifting in the x direction. Everything's happening inside the parentheses, so this is all in the x direction. The question is, how much is this shifting? Is it shifted 4 or is it shifted 2? On first glance, you might say 4. However, it's not shifted 4. I'm going to do a quick, just let my graphing calculator show me what's going on, and then I'll see if I can explain it. Okay. So here's a graph of y equals x squared. And I also want the graph of y equals, in parentheses here, 2x plus 4, close parentheses, save it, no, squared. There we go. Now save it. And when I draw the graph, what happens? Well, it's definitely skinnier than it was before. That's the effect of this 2. But notice that it didn't get shifted 4 this way. It only got shifted 2 this way. Okay. Now I view this two different ways. Here we go. Back over to this. That is, if I first of all think of just graph y equals x minus 4 squared, that's definitely not minus but plus 4. That's definitely shifted over 1, 2, 3, 4. Okay, whatever that graph looks like, right? Crosses the y-axis up there somewhere. Then when I replace the x by the 2x, and now I'm going to look at the graph of y equals 2x plus 4 quantity squared, that's squeezing by a factor of 2. Well, it's squeezing symmetric to the y-axis. So this point here stays there. Wherever the intercept was, it's still there. But this thing here now that was out at 4, all the x values are getting cut in half. So where that used to be at 4, it's now at 2. Right? So this is now at 2. And all of that thing got squeezed in. So yeah, you can think of it as a shift of 4, but then it was squeezed by 2. Or I view it this way. I say start with that graph, all right, fine, and then look at y equals 2x. So that's the squeeze. First I looked at the shift and then the squeeze. If I looked at the squeeze first, so this is a skinny parabola now, and then I say, what does it take to get from here to there? Well, I guess from here to there. I don't have to replace x by x plus 4. I actually have to replace x by x plus 2. Right? Replacing x by x plus 2 shifts it 2 to the left. And so that's this graph right here. If you multiply it out, 2x plus 4, it looks like that. So I actually like, inside the parentheses, I like it factored so that there's a 1 in front of the x, because then I can see the horizontal shift. All right. So let's be careful with that. Here we go. Let's look at a sine curve or cosine curve. Let's do sine. How about something like this? Y equals 1 plus 2 times the sine of 3x plus 2 pi. Right. At first, I might look at that and say, oh, a shift of 2 pi really doesn't do anything. Well, it isn't a shift of 2 pi because that's not just an x. Right? There's various things I see here. Right? I see horizontal shift, I see vertical shift, I see a vertical stretch, I see a horizontal stretch. I mean, all 4 elements involved here. But let's take a look at these piece by piece. The plus 1 on the outside, that's telling me the vertical shift. That's telling me this goes up 1 from what it normally would be. The 2 out in front here is a scale factor in the y direction. For a sine, that's actually telling me that the amplitude here is equal to 2. All right. This I would not leave written this way. I'm going to factor that 3 out. So this looks like a 3 times x plus 2 pi over 3. And so yes, so this 3 is telling me the period is 2 pi over 3. And now actually I have the shift here. This is the horizontal shift, and the horizontal shift is 2 pi over 3 to the left. So it turns out that the period and the shift are the same here, but that's okay. The way I view this now is I say, all right, here's my original xy axes. First of all, look at the shifts. It's shifted up 1. So here's my, in red, I'm going to draw my sort of my shifted axis. So there's this right there, and 2 pi over 3 to the left. So I've got to decide how big my things are. So let's call, well, if I said that was 1, pi over 3 is almost 1, so let's call that pi over 3. So my shift is 2 pi over 3. My shift is there. So the x-axis gets shifted up 1, the y-axis gets shifted 2 pi over 3 to the left. Drawing a sine curve. A normal sine curve would start at the origin. The shifted sine curve is going to start at the shifted origin. It's going to have amplitude 2. It's going to have period 2 pi over 3. So there's 1 pi over 3. There's 2 pi over 3. Wow, I got a really small sine curve in here. I'm going to blow it up so I can see something. Right? That's the beginning of the cycle. That's the end of the cycle. That's halfway in the middle. The 1/4 point has to be up whatever the amplitude is. The amplitude is 2. So from here I got to be up 2. 3/4 points I got to be down 2. Right? And then repeat. And there you have at least a few cycles of this thing right there. Step through the process again. I first of all figure out what my shifts are. Vertical shift, horizontal shift. You don't see the horizontal shift here. You got to factor that, whatever the coefficient is in front of the x, factor that out. It's still inside the sine. This is still inside of the sine, but at least I see the horizontal shift now. The 3 right here tells me how much to squeeze in the x direction, so the normal period of 2 pi gets squeezed by a factor of 3. The number on the outside here tells me the amplitude. Okay. Figure out where your shifted axes are. Sine curve is going to start right there, and then move over the period, halfway in between, the 1/4 point up the amplitude, 3/4 points down the amplitude. And there you got your graph. Okay. Let's try one more with the cosine. So this time I'm going to do, I'm not going to draw a graph yet. I'm going to say y equals -2 plus 3 cosine of, let's say, 1/2 x plus pi over 3. Okay, what do I see? What I see is this number right here tells me that this is shifted down 2. This number right here tells me that the amplitude equals 3. This number and that number, I got to factor it out first. So this is 1/2 times x minus, when I'm factoring out, I'm dividing. So this is pi over 3 divided by 1/2. So it's pi over, so that's 2 pi over 3. Right. So this half is telling me that the period now is 2 pi divided by 1/2, which is 4 pi. And that number right there is telling me I've got a horizontal shift to the right of 2 pi over 3. Okay. All right, let's see what we can do. Again, I'm just going to say 1, 2, 3 there, and for the sake of argument, I've got pi over 3's involved, yeah. So if I call that 1 pi over 3, let's call this 2 pi over 3, which means 3 pi over 3 is pi, and then this would be 2 pi, right? That much was pi, so again, so every 3 I'm apparently saying is pi. You can make the scale pretty much anything you want as long as you label it and label it consistently. I'm calling each block here pi over 3. So now, where's my shifted axes? My shifted axes down 2 and 2 pi over 3 to the right. So right here. Okay, so there's my shifted origin. The cosine curve, however, does not start on the shifted origin. The regular cosine would start up 1, and the amplitude 3 cosine would start up 3. So from my shifted origin, I want to go up 1, 2, 3. Actually, let me draw this in blue here. So from the shifted origin, up 1, 2, 3. That's the start of the first cosine. That's my first handle. Now, to get my second handle, it's the end of that first cycle. Where's the period? 4 pi. So from here, I've got to move over 4 pi. So there's 1 pi, 2 pi, 3 pi, 4 pi. So I'm right here. Right, that's the end of one cycle. Halfway in between is right here, and the cosine curve, remember the standard cosine curve looks like that. One cycle starts and ends up high, in the middle it's down low. All right, so in the middle, right here, I've got to be down the amplitude. What's the amplitude? So from the center line, down 1, 2, 3, right? So amplitude 3 generally is from plus 3 to minus 3, but since this is shifted down 2, this is as high as 1 and as low as negative 5, right? Up 3 from the center line, down 3 from the center line. All right, halfway in between those two now is, where's halfway in between? Right here. That's where I should hit the center line, and halfway in between these two, I don't have that in the right, do I have that in the right place? So there's 3 pi, there's 4 pi. No, my halfway in between, I'm going to erase these two. This one and this one. Let me try a little bit better. Halfway in between, I think is right here. So down 1, 2, 3 from the center line. That looks better. Now halfway in between there is right here. And halfway in between here is right there. So there's one cycle of my cosine, right? It's got period 4 pi, but it's been shifted over 2 pi over 3. Okay? If I were to go backwards here now, that would get me to here, and to here, and to here, to there. So there's 2 cycles. Okay? Find the shifted axes, then with the cosine curve, start up the amplitude and go down the amplitude in the middle, ending back up, whatever that amplitude is. Right? There we go. All the 4 transformations all in one graph.